Okay, so I'll share my screen. So in terms of the skills, these two pipelines are pretty useful to just lean on as a way to think of what did you do, okay? And the way I generally describe, how do we teach data engineering, right? I use the pyramid principle. Data engineering is three things for us, right? It's back-end engineering, cloud computing, and data pipelines. Or say, like, the way I think about data engineering is back-end engineering, cloud computing, and data pipelines. And then, the back-end engineering is obviously the building of the Flask APIs, the ETL pattern, Docker. Docker is the cloud computing is the second thing. So Docker, AWS, and then the data pipelines, right? Is well, we actually learned three different data pipelines, but you can think of Airflow through a data warehouse through DBT. Okay, and then if you want to think through the different pipelines we learned, we learned a serverless data pipeline. We can move into that. We learned a serverless data pipeline using Lambda functions, right? We learned a more traditional data pipeline where we, pull data regularly from an OLTP database into a data warehouse. And then we learned an ELT pipeline, right, using DBT, where you essentially dump the data into a data warehouse and then repeatedly transform that data until we can present it, share with stakeholders, either in the form of dashboards or CSV files. All right, so this is just to review what you covered and how to kind of organize this in your brain, right, and how to communicate it clearly. You can look back at this end-to-end pipeline, or you can look at our serverless data pipeline, right? And there's a good amount of information here, and think through like how this connects. And then I put a link to the code so you can review, these components as well. All right. The next thing, this is new material, is like the data landscape. So the reason why we go through this is because there are so many different engineering positions. These terms, it feels like a new one is invented every 3 to 6 months. So just knowing what they are, knowing how close or how far away from them you are, is very valuable. So in general, like you would be eligible for Python engineering job, backend engineering job, full stack engineer. If you knew HTML and JavaScript, you've covered HTML. We have curriculum on JavaScript if it's something you want to ramp up on. Obviously, data engineer, an analytics engineer, business intelligence engineer, data scientist, you'll be eligible for that. Data analyst. Data scientist, you would not be, but as you'll see, you're pretty close to it. I would stay away from it unless it's something that you're really interested in. And then cloud engineer. Cloud engineer, DevOps, AWS engineer. These two are really like the sweet spot kind of for you all. And then to just show you this, I developed this thing, this diagram. So these are your skills, right? Everything in the red is what you've learned, right? So here's your back-end engineering skills, and you can see there's the Python engineer. And then it goes more back-end with like Bash, Docker, AWS, right? Cloud computing. So you can see this is what involves a back-end engineer. If you're just talking about this kind of what you'll think of as operations, like what supports the code, that's DevOps, right? And that's Bash, Docker, AWS. It also can be like CI/CD, meaning when you push your code to GitHub, that automatically runs tests. If you've learned about GitHub Actions or heard of them, right, that also can be involved in like a DevOps type role. Now, if you think about it, so then what's kind of the next like core data engineering skill set? You take your backend engineering, and then we add in, and we have our backend engineering, cloud computing, and then data pipelines, right? So that's kind of our data engineer. Python and SQL is at the center of everything. So this is kind of our key core data engineering skill set. And then over to the right, you see I'm saying this is more analytics focused, right? Here's where DBT, this is further on our pipeline too, DBT Tableau, right? So this skill set in itself, over to the right, just knowing Snowflake, knowing DBT, knowing some data visualization, that's called an analytics engineer or a business intelligence engineer. In fact, just knowing like Snowflake or an analytics database and DBT oftentimes will qualify you for an analytics engineering role. Okay. In fact, I just spoke with somebody today who was looking for just that skill set. So this is an analytics engineering. Is that end of the pipeline that we saw here. Okay. Well, we do have material on Tableau, but like honestly, the data storytelling is the more important component of that. In terms of data analyst, this is the most, I'd say, like vague term probably of these skills. It can mean anything from junior data engineer. We have a student that's a graduate who's like in the final rounds for that position's data analyst, but it really is like junior data engineer. But typically, like the sweet spot, typically what it will mean is one, data analysis. If you think about what we did at the end of the course, knowing pandas, right? What we did, that data storytelling. So that that skill set that we did at the end of the course, which obviously you're eligible for. It can also, oftentimes you really need to know SQL. It leans more on SQL and a little bit lighter on Python, and so it'll be a lot of SQL, and then it could be a lot of DBT and Tableau as well. All right, which aligns with the SQL material. Data scientists, you can see, is kind of like they expect you to have this data analyst skill set, but then also know essentially some machine learning algorithms, right? These are tools as a way to get insights, but then you want to communicate them typically as a data scientist. So the end result oftentimes is Tableau or some sort of presentation displaying the results. So it's kind of like this data analyst plus type position. And you can see like here's, linear regression, random forests. These are all different kinds of machine learning algorithms. And then NLP is like natural language processing. Again, like if you like really hit it off with like a data science role, or a person that's willing to hire somebody with your skill set, or it just seems like a good fit, we have all this material. We were originally a data science boot camp. So all this material is there for you, as is deep learning material, feature engineering, feature selection. This is more adding this process. Feature engineering means kind of like which are the columns that are most useful to making a prediction, or actually coercing the data, and selection is then selecting those columns most useful to making a prediction. That's more of a machine learning engineer skill set. It also, this is all fluid, so data scientists probably should know this as well, but ML engineers certainly are expected to. But you can see like an ML engineer, they oftentimes are asked to do like end-to-end machine learning, model development and deployment. It's a lot. So oftentimes they're quite good back-end engineers and know a lot of your data engineering skill sets, but then also know this component, right? So that's why like we don't even teach machine learning engineering, as it's just so much curriculum. That's part of the reasons why we stopped being a data science boot camp, was we saw, okay, we have to teach 10 months worth of curriculum. This last step, this is ML Ops, all right? So ML Ops, these guys effectively make the machine learning engineers' lives easier by taking care or supporting them by, if these data pipelines are built, they'll help build them to say collect the data and feed it into a machine learning model, right? If someone wants to make a prediction, maybe I can show you. Let me share my screen. If you, let's say you want to get some sort of what would be a good example? Like an estimate. Let's say we're like Glassdoor, and what Glassdoor does is they estimate various salaries when they see a position. All right. So in order to do that, what do? They take in features like the city, right? Is it like New York, San Fran, whatever, right? And they know that a certain degree of salary is associated with that. The position, right? The seniority. All these things are features, as you kind of know, fed into a machine learning model. How does this stuff actually go to a machine learning model? Through sorry, my handwriting sucks. Through Flask, okay? Through making a request, oftentimes like a post request, to an API, and then it goes into a machine learning model, which will take these features like somebody's city, say it was New York, the position, let's say it's data engineer, and seniority, junior, and give you back an output of, hey, I expect you to make 85K per year. All right? Again, how do you get that there? You make a post request, basically. Predict, let's say you make a post request where you submit params of these attributes. New York, data engineer, junior, and the response back from the API is 85K, right? So you can start to see how like being a good backend engineer is pretty important for that. And then how do they know this? Well, they collect a bunch of examples of, what were the various positions, what was the listed salary, and then from that the model makes a prediction. So how do they collect all that data? Well, by building a data pipeline, right? What you all did. Okay, so that's why you can see like your data engineering skill set actually, it's like data engine is a lot of the fundamentals for one day, if you wanted to, becoming a machine learning engineer. In fact, you see people make that transition all the time. But typically what I recommend is do that after a couple years, become a legitimate data engineer first, have that as a professional level, and then add on these other skills. Like I said, we have had students go directly into a data science realm, but my view is you have to learn these skills anyway. Like this should be your priority regardless of your title. Okay. Let's take a look at this and maybe just look at it, and I'll pause and let me know what questions might come up.
So if someone's like, I think it would be cool to have an ML engineering role down the line, would it make more sense for me to try to go for a data engineering role than like an analytics engineering role?
What I would say is like these are what you want to do, and what I put in this reading is basically you want to emphasize your Python and SQL skills. Like this is the core of everything. So as long as you have a job that is getting you on that path where you're able to, get better at Python, get better at SQL, then everything else can come. Like all I knew, like as an engineer, was really Ruby and SQL, and not even that well. But being able to write code at a professional level, right, that was very valuable. And so that's the main skill set that you're looking for. And kind of like I said, that can occur legitimately in any one of these roles. There are like data science roles that are more like what you might think of as data analytics, and there are data analytics roles that are much more like data engineering. Like I'm talking about very very recent examples, seeing this all the time. So what I would emphasize is Python and SQL. And the other thing I talk about here that's important to note is the job title. So we talked about the job title will oftentimes not match the underlying skill set, and the job description, believe it or not, oftentimes will not match it either. And the other thing is just finally, as you get further along in the process, especially let's say they give you an offer and it's like a data analyst offer, and you say, hey, I'm a little concerned, just it seems like I want to make sure that there's a way for me to develop my Python engineering skills as I go along. that's the time to, to assess that, right? And they can, what you can do is say, like, okay, do you think maybe 6 months down the line, 9 months down the line, that's a viable career path for me? And then, get the answer and then hold them to it. 6 months down the line, talk to them about that, right? And if that's not the case, then you can decide where to move forward. But you'll be doing so, right? Like with bringing a valuable skill set to the next employer. Like that's basically like what you're doing here. Is like unfortunately, like you guys have very legitimate skills, but you want to. It's the way to get that really recognized in the marketplace is by getting jobs where you're doing that professionally. All right, so that's what you're trying to build.
Thank you.
Mm-hmm. One other thing I wanted to cover was just what you typically see then, like in the interviews. The typical thing, like the kind of absolute backbone, right, is Python and SQL in all these jobs. It doesn't matter. Like in all these jobs, they will likely be asking for Python and SQL, especially at kind of like this mid-level / junior position. If you've done it for 5 years, maybe they'll lean on something else. But regardless of the job here, there'll be, maybe with the exception of cloud computing and DevOps, probably just cloud computing, they'll ask you mainly Python and SQL questions. Of those, though, where does it lean? When you're over on this side, right, data engineering, Python engineer, backend engineer, right, you'll expect to see more Python questions. You'll expect to see more of the algorithm type questions, right? Like we'll cover algorithms starting today, but if you find yourself, you'll see if you're getting the interviews and where your direction takes you. But the more that it's a back end position, you can expect to see questions a little bit deeper in algorithms, meaning like linked lists, which aren't that. It's just another topic to learn. Trees. And just reviewing your classic Python leak code questions. These positions, like the analytics engineering, data science as well, data analysis, it will lean more on SQL. Oftentimes it will be a combination. But what I've said in the past, I might have to update it. But what we've seen in the past with these kinds of positions is like SQL leak code level 2, right? Like the medium, maybe even the hard for SQL leak code, and then the Python easy leak code easy questions. All right, so they won't. You can expect there'll be harder kind of SQL questions than the Python, at least the way that leak code rates them. Other things to talk about. These questions, obviously, you can also see, more like take homes, but honestly, we've seen them throughout, right? I think you just saw it, like Michael posted it yesterday, right? Like that you can see these take home exams in a data engineering position as well. Lately, I've been seeing more leak code style question. I don't know how big of a trend that is, but it feels like we were seeing more take homes like a year ago than recently. But again, I don't know. All right. I'm trying to think if there's anything else. The other thing, just going back to this lesson a little bit, one thing I have here is like, okay, where does data analysis come in our data pipeline? There's really like, so why do we learn this thing and how does it fit in? I'd say there's really like three places. One is at the source layer, meaning, we're trying to figure out what data is worth collecting, right? So we can do some upfront data analysis to see, okay, is this a complete data set? How representative is this data? How recent is this data? If we get these features, are they predictive of anything? Do they change, right? How clean is this data? Like how much work is going to be involved, right? So just in terms of choosing data sets to repeatedly pull, right, you'll probably, it would make sense to do some data analysis at that stage, right? The second thing is then, okay, we're going to build this data pipeline where we're going to be like, coercing our data. All that stuff takes work, right? Like coercing our data, selecting data, things like that. How do you know where to put that effort? So there you can see we pull the data and we just load the raw data in an S3 bucket. Remember, this is the stage, this is like your data lake. This is the stage that a data scientist or you, right, can pull the data from an S3 file, like a CSV file, use some pandas, start exploring the data, figure out, okay, what data is worth transforming and ultimately loading into like an analytics database, or really like just what's worth coercing, what's worth putting in that engineering time. That can take a while. Like for a project, you want to do it relatively quickly, but in the real world, right, they could be, if this is a couple month-long projects involving 5 engineers, right, that's a couple $100,000. So they're going to want to spend some time figuring out where is it worth, putting this engineering resource behind it. So that's the second place is, okay, once we have this data loaded into our data lake, what data do we want to spend the engineering time on to actually move into a database, but really, where just do I want to spend the time to clean up the data? And then the third thing is, okay, so we connect this thing. We are, I want to get a better thing. We want to present it to these different departments. You can imagine they're doing some analysis on that here, right? Or lots of times you might be asked to build the dashboard essentially. So you'll want to first use pandas or use Plotly to plot some charts, kind of do a quick minimum viable product, just build it in pandas and Plotly, and then turn that into a dashboard, right? So it's like three parts that you can do the data analysis and probably makes sense too. The first is what should I pull in, right? So we want to explore the data there. The second is, okay, we're pulling in all this stuff, right? Data lake, hopefully not a data swamp. But what do I want to spend time coercing now that I have all these sources and put more engineering effort into? And the third is, okay, like we want to start presenting this data. We're probably going to update how we think of this data and what's valuable over time, right? And that involves some analysis and building some initial plots before then turning them into a dashboard in Tableau or Streamlit or whatever. And one thing I should get out of the way before, just I don't know that I wrote it down in the curriculum, but you should absolutely understand this. You may see them list something like Google Cloud instead of AWS or Azure instead of AWS. Oftentimes, that's not always, but oftentimes, I'd say over half the time, probably closer to like 70-80% of the time, that is fine. You knowing AWS and not Azure, they are fine with that. Same thing with any of the databases, right? The fact that you don't know, well, you really covered the main ones, Redshift, Tableau. But if there are like little databases you don't know, you have the skills to learn them, or oftentimes they'll be okay. You've covered enough of them that it will be fine. One other thing to cover is like even languages, especially if you see Java, Scala, Python. Oftentimes you only need one object-oriented programming language. We've had a student get hired as a backend engineer in American Express in Java he did not have a previous comp sci degree. He just knew object-oriented programming well enough to get that job. All right. So, even if ultimately the job is not in that, it isn't in Python at all, it's concepts. Like this is why we focused on the fundamentals of object-oriented design, object-oriented programming, testing, clean functions, right? This is why. So do that. And then the last thing, Michael reminded me of this today. We had in office hours, he said, about just-in-time learning. And that's very true. It's like, okay, like I got the interview for this job. They're asking for like PySpark. I haven't, I'm afraid that might come up. Like go to the website. We have 10 lessons on PySpark. It goes very in depth. Like I've taught senior level people this material. And this will, really help. Same thing. If there's other material that you need, please, that you feel like is not covered, please ask. Just Slack me. I may have something on it. There's like a whole nother set of curriculum that has not been deployed. It just takes too long to load it all to Canvas, but I'm happy to make it available to you. All right. Cool. All right. In terms of the career tracker, and then I'll let's just quickly go through this again. So basically, what I'll ask you to do is make a copy of this. You can do File, make a copy, replace the name with your name, and then the main things for you to focus on is going to in like this initial stage, right? Like there's different is going to be like the networking, right, and education. All right, if you want to like just think about what do you have to do right now. It's like begin networking, give you some steps for that, and then also like begin moving through this stuff. Kumar, do you know what was the name of that resource that you mentioned to me for interview prep? Oh, you put it in there. Okay, Strata. This looks very good. I hadn't heard about it till like 2 days ago. But this also, I think that this might be like, I'd have to look at it a little bit more, but this may be like one of the best resources. So if you go to like explore coding questions, and then you can go to really, right, like any of these are fine. If you want to focus on just data engineer, that's fine too. All right. And then you can see these are various questions that they have. I think a lot of these are SQL questions, right? But this is a good thing to practice. And then what you would do is, as you get them wrong, which you probably will get to start with, if you've never done LeetCode before, you probably almost get all of them wrong. Then you'll go to this part and just put that in. If you don't want to put in like, I would say just say put it in. All right. And then over time, like I said, you'll study. This is an efficient way to spend your time, right? Because you're focusing. There's so many LeetCode problems. You're going to forget them over time. You want to identify which ones you need to go back to. All right. So you'll put that here. And then also it's for us as teachers to be able to see a theme, explain the concept to you in a one-on-one, and then just clear it up and we can move on. So the main things, right, is networking and education. So these are various tools just to talk through some of these education resources. This is very good, this Mode SQL material. Like I said, you'll probably see like 60-40 SQL to Python material. This you all know, I believe. But it's good just to, if you feel, like you want to review any of this, go review it. But then it will eventually, right, like outer joins, reviewing that, left join, full outer join, the union, right? These are things that maybe that we saw a little bit less in the curriculum. Self joins we haven't covered. I think we will cover them. And then these you don't need to focus on as much, except for what you saw in the curriculum. Subqueries, window functions, and then if you want to look at this as well, that's fine. Performance tuning. All right. So this is useful just overall. LeetCode you know about. I put a list of SQL problems. NeetCode, a lot of people have referenced this. We'll start going through this kind of material, but you can see this is more Python algorithm type based. But what you can go through, where all this is recorded, but what you can go through is essentially up to this section. You won't have to go past here. And this is a pretty good prioritization of these. I put this in here as well. Work through arrays and hashes, 2 pointers, binary search, sliding window, linked list. You can really do it in that order. Okay. Python koans. This is like reviewing Python. We showed you this before, right? This is like just do these little steps, get the test to pass. It's just like a way to like sharpen your blade, like keep things sharp for you. And then right, and this I like I said, I think we'll move this. Let me just move this to the top. Oopsies. Yeah, I do like this resource. I think it's very good. Um, and then, okay, and then these books are good. I chose these because they're relatively short, so you can, I don't know how you take public transportation, but if they're on like, you bring them on a train, etc. They're good, like, just like giving context, and you're gonna have to talk technically, and like, so just right. A lot of this is review for you. Build a data lake, ETL, but these are also obviously the kinds of questions that you'll see in an interview, right? And so having these available to you, this is a really nice way to review. Going through this, so this one's is called the Informed Company, right? You wouldn't. It's not a very great title. And then Data Pipelines Pocket Reference Book is not there. Data Pipelines. But you can look at this. It should be, there you go. Data Pipelines Pocket Reference. All right. So this book as well, Pocket Reference, right? So it's pretty small, but it's a really good review of the material. Okay. And then Pramp and interviewing.io. A lot of the interviews are going to be verbal, right? Not always, but when they give you these leak code problems, they may ask you lots of times to talk through them. So doing that itself is a skill, and Pramp allows you to, I think, I've never done it personally, but it allows you to talk to, peers and practice with peers on leak code problems. Okay? So, doing it anonymously effectively, right? You never have to see that person again. Can be a nice thing. And then interviewing.io is effectively the same thing. And then these two books are good, like, networking books. This Never Eat Alone, I read this years ago, like maybe a decade ago, but if you want to know, like, even more networking tips, he goes a little overboard, but you will have plenty of ideas. And he ended up being very successful basically through his networking approach. I think he's like one of the youngest ever, I don't know, executives at a consulting company or something like that. And then this, I think, is very practical. This 2-hour job search, this guy, he runs the career services at Duke's MBA program. And I found his advice like very practical as well. So these are, two good books. If you do audiobooks, or want to try it, audiobooks are fine too for some of this stuff. So I wanted to share that. So what are the main things, right? Networking, education, right? And we just went through some of the education steps. All right. Let me cover one last subject, and then I'll deploy this curriculum. Anything before I move on? Okay.
Okay.
Go ahead.
So system design, how that play a role in the interview?
It can come up. I think that these will go through some of it. The other thing is, this was in some of the, if you go back, especially through that, around when we did the Lambda functions, right, we had various diagrams on system design. I wouldn't go too much beyond that. For example, like, you can learn, I forget about the principle, I don't know, there are like these various principles you can learn and things like that. I haven't seen them come up too much. If you Google like system design interviews, and they go super deep, like very far beyond what we've learned, I don't think you need that. I haven't seen that come up too much. But things like, you can see here, I talk a little bit about DynamoDB, right? BigQuery versus Postgres, right? ELT versus ETL. Like, those are the kinds of questions. They're right. Athena versus Snowflake, right? These are more of the things I would Lambda versus event-based architecture, Airflow versus Lambda, right? That, when you say system design, I would think of it more in that vein, like which tools to choose for the job. And remember that we also saw a couple of the diagrams, like with the data lake, etc. It's in this serverless, I think, around here. EC2 versus Lambda, data lakes versus data warehouses, right? You can see them here as well. I'll try to move them to organize these a little bit better for you, but that's what I would think through. And the other thing is just, right, the design patterns we learned, like, model view controller, the adapter pattern, an ORM, right? Those things. Like, why do we use them? All right, like for any of these things, you can just ask the question essentially, like, why? All right, and that's what these are basically, like EC2 versus Lambda. Why? Why one versus the other? Lambda versus Airflow. Why one versus the other? Right? Like, try to challenge yourself. Like, ask that question. If you can't find, you can always ask, ChatGPT. Like, you want to go beyond that, but you have the framework now, like the principles, to then vet ChatGPT's answers. So that's how I have found it useful, is to kind of think through the question, ask it to kind of spark some ideas or propose some answers, and then you are evaluating them. All right. Cool. Okay, the last thing I wanted to talk about is just like setting a schedule, okay, for yourself. And this was Wayne's advice. Good advice. So in terms of, it's also like what I've seen a lot. It's part of the reason why basically the main inspiration for why we do career service this way, we meet twice weekly, is to continue a routine. Because there's so many times that, and I think it makes sense, it's like you're part of this structured program, you have a lot to do, right? You have this momentum, and then all of a sudden the structure starts to disappear, and it's hard to know how to spend your time. All right, so that's why we're meeting Tuesdays and Thursdays anyway. But this is, I've met with people from the old boot camp I used to work at, and I was like, this is what your schedule look like? And they're like, exactly. So basically, like, this is a bad schedule, where it's like, okay, wake up around 10, or get dressed around 11, you'll finally sit in front of your laptop. At 11:30, okay, I'll move over to LeetCode problems after I've checked the news. Okay, wait, now it's time for lunch. All right, cool, now I'm back. Do scan LinkedIn, apply to a few jobs, and then do LeetCode. It's like you did 2 hours worth of kind of like productive work, unfortunately, which is fine. Like, I'm sure that will happen, like maybe even as soon as next week. But you don't want that to happen every day, obviously. All right. So for me, I'm someone who has to work on their own and set their own schedule. Like, I'm in a coffee shop by 10 a.m. every morning because I just don't work well from home. I know I'll get distracted, and it's not pleasant for me either. I don't want to be in my apartment. So get to find your happy place to work. Figure out you can experiment with different places. That's what I do. But try to start working and be focused by 9:30, 10 a.m. Like, set an alarm or make sure you're going to sleep at a normal hour, and then consider how many hours are you going to have in the next week. I'm not saying you have to spend 40 hours a week, but rather you figure out how many hours do you have. If you're not working, right, if this is your primary thing, probably should be around 30 hours, right? And then you'll have these 6 hours after class. And then here's how to like divvy up your time. So you want to put a baseline, I would say, of like a quarter to 40% of that time networking. By that, we have various lessons on what that involves. But you'll see, like, you can sign up for Lunch Club. You can sign up for this data engineering mentors thing, which would just regularly connect you with like a one-on-one conversation with people. And you can see how successful that is for you. For me, those resources, the Lunch Club especially, has been very successful. Meaning I've met really interesting entrepreneurs that are there, and like potential partners for your externships and things like that. So like 25%, 40% of the time should be spent networking. And like I said, that involves a range of activities. You can 40% of your time, right around half, right, of your time is improving your technical skills. Now, like, I put down, like, that means like LeetCode. But if you're, deep into a project that you're really passionate about, like, that's fine too. I would say you still want to try to put maybe like half an hour into like technical interview prep each day if you can. But you'll talk with your instructor or me about that. All right. And then here I put around like 10-15% of time on technical communication, really meaning like reading the books, Pramp, outlining. For those of you who did outline, or even if you didn't, I really can't speak. I don't know how I would think without outlining. I recommend it. And then, especially to begin with, you don't have to be sending applications, but if you feel ready, if you want to do it, I'd say after a couple of weeks you want to start. But in this first couple of weeks, you can just focus on this and make sure this is secure, and then you can start applying. In terms of job applications, the most successful, both for like me and students, has been Slack. I have listed. Look, let me stop sharing for a second. I'll pause this. If you landed your dream job, like what would that look like? Why would that be your dream job? Right? So one would be like maybe the technology that you're interested in. Like ultimately, I really love just like the insights that you can get from data. So for me, I'm pretending to be you. Ultimately, I really love like the insights I get from data. So I love projects that then are tied to like these kind of machine learning applications. Like I find that really fascinating. Or maybe it's things that are tied specifically to a product or whatever. Or I don't know. Or you just really love working with Python, right? One thing is just think through the technology. Meaning like just think back on the course, reflect on the course. And what did you enjoy? Like, what did you really like about it? Like, which parts did you really enjoy? And this might take a moment to like think about what do you genuinely enjoy. The same thing goes to like the domain. I would say it's like what do you genuinely enjoy? Like for me, like I switched my career like 5 times, so that took a moment to figure out. But what I like is like messy kind of things that involve lots of different skills. Like one of the reasons why I love teaching, well, it allows me to see different elements, whether it's, presenting information or kind of like building a community, or just gives me opportunity to like learn different topics, right? And then, storytelling, things like that. So I like these topics for me that involve like a combination of skills and allow me to just go deep in different places. But like, what do you genuinely like? Not like I think this is going to be big in the future. Like that is a turnoff to someone working in the field, and I think not like not ultimately going to be very productive for you. Like maybe you'll be able to power through for like a couple years, but it's not going to be great in the long run for you. In terms of just as productive or as enriching a career as you can have. So it's like, what are you actually interested in, and a way to figure that out is, again, like kind of like what do you see yourself spending your time with, or if you had time to do a project or you were going to do a project, what would that be in? So I can just speak from my own example. The way I figured out I was interested in education is because all the projects, all like the hobbies I did were like these weird little education projects. And it wasn't like, I really was kind of dense about it. I was not like, oh, I want to be a teacher one day. It was actually, I found myself reading a book on how to be a better teacher, and then was like, I'm not even in this field and I'm an engineer, I'll apply. So it's like, what do you find yourself interested in? If you're going to build a project, and what would it be? Like what's a project that excites you? And if this relates to an actual industry or something that's somewhat practical, that's great. But it doesn't have to be that, like I built something for like people over in India to learn, and I just went into international development and education, and I'll show you, like I connected with people in that realm because of that. Or like another thing is just like, what do you like to read books in? Like meaning like kind of like nonfiction or type of books. Or if you had the time to read books, what would you be reading those books in? Like I told you, for me, like I was fascinated about just like how people learn and what makes a good teacher and things like that. And so like doing that allowed me, one, to discover what I was interested in, but then two, guess what, like this is how you show that you're interested in this stuff. Now, why is this really valuable? Like kind of picking something very, very particular to you. It's very valuable. So one is, if you just go up to a person and kind of say, do you know anyone, or I want to become a data engineer, do you know anyone, like that can work, right? Like some people can really help you, but it's a lot more useful oftentimes if you're like, ideally, like I don't have to, but ideally, like I'd be able to one day work in ed tech, and then they'll start thinking, do I know people that work in this kind of field? And that jogs their brain generally more. And then when you ultimately meet that person, it's not like I'm just looking for any job. No, here's a real fit here. Like the person that I'm about to hire aligns with what they've done in the past. And so one, like I expect them just to know more about it. And two, like I expect that they're going to keep learning about it. And like I can just tell you, like, employers absolutely value that. And it comes off as genuine, and it's flattering to them. Like I actually work in the field, and now here's this person that wants to do what I do, right? So that's how, and then ideally you'll have lots of questions from there, right? Because this is actually what you want to do. I may just screenshot this person's blog because it's behind, but Allison Quaglia, she wrote, breaking into, I think it was like, Into the Unknown. Here it is. Yeah, this is the issue, is that, hold on, let me stop sharing for a second. But I signed up for Medium so I can add components of this to the curriculum. Okay, so Allison, how did I even hear about this person? Well, she graduated from Flatiron School after I already left, and she somehow was connected with a friend of mine from high school who reached out on who I'm guessing she asked, to get an introduction to me, and he did, and I was happy to talk to her, right? So, she just kind of used the power of her network. But this is what she said, and I just think this speaks so true. I've heard so many people lament that they hate cold emailing and how fake it feels. So I have to ask, why are you being fake? There's no need to pretend to be interested in someone or some company when you really couldn't care less. There are countless companies and individuals doing really cool stuff out there. If you see someone with a great portfolio, impressive project, tell them, right? And so like the Joan Harris thing, with genuine curiosity, admiration for their work, they'll do it. I've had some great conversations with people whose work I truly admire. A cognitive dress using Watson. I don't even know what that means. Using Watson. Disney Imagineering. That's pure CSS art that looks like oil paintings. UX engineering. Her first job, like 2 months afterwards, was working at Pinterest. And she says here she applied to very few positions. You can basically talk to any of these people and find, and if what actually sparks what you're interested in. Hopefully there is something. So that's what it's like. That's the people that you want to talk to. It's people that you want to talk to. Like, that's the people. All right. So that's what I recommend. Like the reason, like I like, if there's a book types of books you read or blogs that you find yourself reading, like reach out to the authors. Like they'll be happy to talk to you. I showed, just to show you, also just another sneak peek of the curriculum. Just to give you like some examples of like people that I've reached, here when I was a law school grad, like Andrew Yang, the presidential candidate, he never ran a tech company, even though he says he did. He ran Manhattan GMAT, which maybe had a website or something like that. But I told him, I'm not quite sure about this law thing. Do you think maybe I emailed him afterwards after he gave a talk at the school and said, do you think maybe I could, be an instructor? And what does he say? He says, listen, not really. Well, your teaching experience is limited, but why not? Well, I'm open to considering a fit. So I've CC'd this person. It's like, well, he's the CEO. So, that's helpful. Like the person who's like book, I read like years ago, I emailed her just like last week and said, hey, thought of your book. I loved it, because of the recent news. And, she's the head of sociology department at University of Michigan. And, her automatic email says like, I'll get back to you in a month. And she wrote back to me an hour later and said like, wrote more than this, and all I said was, I'm an educator and I loved your book. But you can obviously do this with blog posts, right? And ask them. When I was in undergrad and I had to do like this 20-page research report on it was literally on like the Wild West. I could not understand. I forget it was like how like gold mining actually worked. I don't remember. But I called the author and he just talked to me and he filled in the gaps for me. Like these people will, if you have a question, ask them. And then how do you you can just say, well, I love this topic. I'd love to do this kind of work one day. If you know someone who's looking, who's looking for someone or any availabilities, please let me know. But either way, I really appreciate the advice. Something like that is fine, right? And then just to, what happens oftentimes is they won't know anyone. But then, let me stop.